Hello, mathletes. Welcome back. Today we're going to learn what happens with these rules of exponents when we've got some division. All right, let's try x to the 6th over x to the 4th. X to the 6th is the same as x times x times x times x times x times x over x to the 4th is x, 1, 2, 3, and 4. And remember, 4 times x would be x plus x plus x plus x. So it's not the same thing as x to the power of 4. X to the power of 4 is x times itself that many times. Okay, obviously, right, we're way beyond that, right? All right, x over x cancels, x over x cancels, x over x cancels, x over x cancels. Okay, in fact, how many are going to cancel is just that denominator is many, right? So how many are left is the numerator many minus the denominator many. So what we do is we're going to go x to the 6 minus 4 to get 6 minus 4 is 2 to get that x squared. And indeed, x times x is x squared. So yes, we can write it all out, but our shortcut is going to be to take the numerator exponent and subtract the denominator exponent. Okay, well, what if that numerator exponent just, what if that numerator just wasn't even there? What if there was just 1 over x to the 3rd? What does that simplify to? Can we write that as x to some power, not as a fraction? Well, yes, we can. And this is going to take a cool bit of math pattern writing. So let's start by writing, okay, x to the 3rd is x times x times x. X squared is x times x. X to the 1 power is, of course, just x. X to the 0 power is, well, each time we do a step lower, we are dividing by x, right? To go from here to here, I divided by an x to get to that step, right? To go from here to here, we divided by an x. We got rid of an x. So to go from here to here, we need to divide by an x. And what's x divided by x? Well, anything divided by itself is 1. So it turns out that no matter what x is, anything to the 0 power is 1. All right. Then what is x to the negative 1 power? Well, we're going to divide by x again. So this is going to be 1 over x. So having a negative exponent does not actually make the number negative. It makes it a fraction. Let me say that again. Having a negative exponent does not make the number negative. It makes it a fraction. That's kind of a tough nut to chew, tough nut to swallow, but just chew on that for a little bit. So x to the negative 2 would be 1 over x. We divide by another x, so 1 over xx, or 1 over x squared. I didn't leave myself a lot of room to write that. And we'll do one more. X to the negative 3 power is 1 over x to the 3. All right, so definitely copy these fun facts into your notes, please. All right, well, this is going to make perfect sense. So if we go back up to this example, I hadn't finished with this. What is this 1 over x to the 3rd? So that would be x to the negative 3 power. And let's take another little example here. What if I had x to the 4 over x to the 6? So I have more x's in the denominator than I do in the numerator. So basically I've got x, 2, 3, 4 on top, and 1, 2, 3, 4, 5, 6. Okay, so my rule is to subtract those exponents, right? So my rule would be, okay, my answer is x to the 4 minus 6. Always go top minus bottom. So x to the 4 minus 6. But 4 minus 6 would be x to the negative 2. Okay, well, and indeed, if we actually write this out, cancel, 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 cancel. If you cancel everything on the numerator, of course, that means that you have a 1 in the numerator. So we'll write that 1. And then we've got x squared in the denominator. So there's another proof that that rule works even if we have negative exponents, even if we have more bigger exponents in the denominator than we have in the numerator. The whole thing just works no matter which way you slice it. It's a beautiful thing, isn't it? Come on. You have to appreciate the beauty. All right, so let's take a look at some examples. Actually, I'm going to turn the page. Okay. How about it seems like somewhere I saw one of these problems. I don't remember where. There was a whole bunch of complicated stuff, and then on the outside there was a to the 0 power. So please take note. Don't do a bunch of work if you don't have to. If you have a whole bunch of stuff and it's to the 0 power, anything to the 0 power is 1. So okay, but we don't have that here. Here's what I would recommend doing. Put any negative exponents, switch the side of the fraction first of all. So here's what I mean by that. Your x's here have a negative power and your x's here have a negative power. So I would just, it makes it seem a little more straightforward if those are positives. So let's put the x on the other side and make that x to the positive 9 up here and x to the positive 4 down here. Because if x to the negative 3 means 1 over x to the positive 3, then if you don't want to deal with a negative exponent, you can just change which side of the fraction it's on to make it a positive exponent. So that's kind of handy dandy. You just change which side of the fraction it's on, and it changes its sign, the sign of the exponent. Okay, so that x to the negative 9, we can just pop that up into the numerator and becomes x to the positive 9. And the x to the negative 4, we're going to pop that into the denominator, it becomes x to the positive 4. All right, y squared is already a positive exponent, so that has to stay there. Y to the 10, the same thing. It's already a positive exponent, so it stays there. But these z's, they both have negative exponents, so we're going to move those to the, we're going to switch sides of the fractions on those as well. So the z to the negative 8, we're going to pop that up into the numerator and call that z to the positive 8. And that z to the negative 3, we're going to pop that down in the denominator and call that z to the positive 3. All right. Now let's do our handy-dandy subtraction rule. So we've got our, and of course we're only going to subtract the ones with the same base. So because it's only the ones, sorry, I keep flipping back. It's only the ones with the same base that would actually be canceling out. If I had x to the third over x squared, y to the third over, yeah, okay, we'll just leave it at that. X, y, x, x. Okay, these x's are not canceling with the y's, they're only going to cancel with the x's, right? Okay, so it's only the same base that the subtraction rule works. Okay, so let's start with the x's. X to the 9 over x to the 4 is x to the 9 minus 4. 9 minus 4 is 5. X, or y to the 2 over y to the 10. So we have two options here. We can go y to the 2 minus 10 is y to the negative 8. So we can write it as y to the negative 8 right here. Or we can write it as x to the 5th, y to the positive 8 down in the denominator. Okay. And then we'll have z to the 8th divided by z to the 3rd. And 8 minus 3 is 5. So we've got z to the 5th power as well. All right, and let's not forget that everything is then going to be raised to the 5th power. And I've got my z to the 5, since I'm doing this two ways. Okay. So whichever way you decided to write it. Finally, we can take care of this 5th power on the end. Just like if we had been multiplying, just like if they were not exponents, if you just were walking around and you saw, oh, I've got a number on the outside of parentheses, it means multiply. Well, that's the same rule for exponents. If there's an exponent on either side of parentheses like this, we're going to multiply those exponents. That's the pattern. So we'll have x to the 25th power, y to the negative 40th power, and z to the 25th power. And likewise here, x to the 25th, z to the 25th, and y to the 40th down here. Same answer, just different ways writing it.